A jet engine with a fan wider than 3 meters just completed over 50 test starts in Russia, including repeated runs at full takeoff thrust, and almost nobody outside aviation circles noticed. That engine is the PD-35, and it's the highest thrust civil aviation program Russia has ever attempted to build. By the end of this video, you'll know exactly why Boeing and Airbus engineers are watching this program, why it almost died in 2022, and whether it can actually reach the sky. The PD-35 is being developed by the United Engine Corporation through its Perm-based design bureau, Aviation. Its target thrust sits around 35 metric tons, with some Russian sources citing figures up to 38 tons, depending on the testing mode. That number matters because it places the PD-35 directly in the same thrust class as the General Electric GE9X, the engine powering Boeing's 777X. It also puts it in direct competition with the Rolls-Royce Trent XWB family, the engine currently powering the Airbus A350. The fan diameter alone exceeds 3 meters, making it the largest fan Russia has ever designed for a civilian engine. That's roughly 50% larger than the fan on Russia's existing PD-14 engine, a massive jump in a single generation. United Engine Corporation has confirmed the PD-35 relies on composite wide-chord fan blades, a first for any Russian civil engine program. So why build an engine this ambitious right now, when Russia's aviation industry is under heavier sanctions than at any point in decades? The answer is a single aircraft program called the CR-929, originally launched in 2017 as a 50-50 joint venture between Russia and China. The goal was simple: give both countries a wide-body airliner to replace aging Boeing and Airbus jets on routes too small for the largest Western twins. After 2022, everything changed. The program shifted toward Chinese primary leadership, and Russian engines were effectively disqualified from international certification. That single geopolitical shift is exactly what gave the PD-35 program its urgency. It's now the only realistic path to a Russian-built widebody with Russian engines this decade. To understand whether Russia can actually pull this off, you need to see where this engine's lineage actually comes from. The SA M146, a joint Safran and NPO Saturn engine, powers the Sukhoi Superjet 100 and was Russia's first modern civil engine. The PD-14, which powers the Irkut MC-21 narrow-body jet, was the next major step up in Russian engine engineering. The PD-35 extends that same engineering lineage, but at a thrust class Russia has genuinely never attempted in a commercial design before. Testing didn't happen overnight either. It started with a gas generator bench test back in 2022. That moved into full-scale technology demonstrator testing by 2024. A real jump in program maturity within just 2 years. Reports published in early 2026 confirmed over 50 engine starts, including repeated runs, specifically at takeoff thrust levels. Those same reports confirmed stable operation at the engine's actual design thrust, not just partial power tests. 50 engine starts at takeoff thrust is not a small milestone. It's the kind of data point that separates a real program from a paper concept. But here's the question that actually decides everything. Does a working engine mean a working airliner? The CR-929 program, originally expected to enter service in the late 2020, has slipped noticeably amid the broader geopolitical restructuring around it. A domestic Russian widebody needs far more than one working engine. It needs a brand new airframe built from scratch. It also needs an entirely new suite of avionics, designed to match that airframe and engine combination. And it needs certification paths at this exact thrust class that Russia simply hasn't exercised in modern aviation history. That's 3 separate massive engineering hurdles stacked on top of an engine program that's still in the demonstrator phase. Western aviation analysts are genuinely split on whether Russia can clear all 3 hurdles in a realistic timeframe. Some argue Russia lacks the supply chain depth in single-crystal superalloy turbine blades, a material science problem that doesn't get solved with willpower alone. They also point to Russia's missing reliability database, the thousands of accumulated flight hours that mature commercial engines rely on for certification. The long-term testing hours mature programs require simply haven't been logged yet on the PD-35, and that gap takes years to close, not months. Other analysts push back hard on that pessimism, and their argument is worth taking seriously too. They point out the 2026 bench test results are genuinely competitive, with comparable Western demonstrator programs at the same stage. Their conclusion is that the technical gap between Russia and the West here is real, but it's not insurmountable given enough time and investment. So where does that leave the PD-35 today? Sitting exactly between a genuine engineering achievement and an unproven commercial future. 50-plus successful engines starts as real, documented, and independently reportable. That part of the story isn't in dispute. A finished, certified, flying Russian widebody airliner is still years away, and every one of those years carries real risk. Think about what a fan over 3 meters wide actually represents mechanically, because the size alone tells you the ambition here. A fan that large has to move enormous volumes of air efficiently, while surviving decades of thermal and mechanical stress cycle after cycle. Composite wide-chord blades are lighter and more efficient than metal blades, but they're also harder to manufacture at scale reliably. This is genuinely Russia's first attempt building that specific blade technology for a civil engine, which is exactly why the 50 engine starts matter so much. Every one of those test starts is effectively Russia proving to itself, and to potential future partners, that this specific technology actually works in practice. Compare that to the SA M146 and PD-14 programs before it, both of which took years between first tests and actual commercial service. If the PD-35 follows a similar multi-year timeline from demonstrator testing to commercial service, a realistic in-service date sits well into the 2030, not the late 2020s. That timeline realistically means the CR-929, or whatever aircraft eventually carries this engine, is still a next-decade story rather than a next-year story. So is this engine really going to change everything for Boeing and Airbus? Or is that framing getting ahead of the actual data? The honest answer sits in between. This program is a genuine long-term technological capacity test for Russian civil aerospace, not a finished product announcement. It's not a Boeing or Airbus killer showing up next year, but it's also not empty propaganda either. The bench test data is real and independently reported. The single most important number in this entire story is 50. As in 50-plus documented engine starts at real takeoff thrust conditions. That number is what separates the PD-35 from every failed or paused Russian engine program of the past 2 decades. Whether it ever powers a passenger flight depends on 3 things stacking up correctly: the airframe, the avionics, and full commercial certification. Miss any one of those 3, and this remains an impressive bench test program that never reaches a passenger cabin. Hit all 3, and Russia has its first domestically powered wide-body airliner for the first time in modern aviation history. That's the actual stakes behind a jet engine most people have never even heard of until this exact moment. If tracking real aerospace programs against the hype around them interests you, there's another video on this channel doing the same breakdown on a completely different aircraft story. Go watch that one next, because separating genuine engineering progress from geopolitical noise is a skill worth building well beyond just one Russian engine program. Go watch that one next, because separating real engineering from marketing copy is a pattern worth understanding well beyond just one port in China.